Okay, so this is a reading from Aldo Leopold's Sound County Almanac, and specifically from the Round River Essays. One of the marvels of early Wisconsin was the Round River, a river that flowed into itself and thus sped around and around in a never-ending circuit. Paul Bunyan discovered it. And the Bunyan saga tells how he floated many a log down its restless waters. No one has suspected of Paul of speaking in parables, yet in this instance he did. Wisconsin not only had a round river, Wisconsin is one. The stream of energy that flows out of the soil and into the plants, thence into animals, thence back into soil, is a never-ending circuit of light. Dust unto dust is a desiccated version of the round river concept. We of the genus Homo ride the logs that float down the round river, and by a little judicious burling, we have learned to guide their direction and speed. This feat entitles us to the specific name sapiens. The technique of burling is called economics. The remembering of old routes is called history. The selection of new ones is called statesmanship. The conversation about oncoming riffles and rapids is called politics. Some of the crew aspire to burl not only their own logs, but the whole flotilla as well. This collective bargaining with nature is called national planning. In our educational system, the biotic continuum is seldom pictured to us as a stream. From our tenderest years, we are fed with facts about the soils, floras, and faunas that comprise the channel of the Round River biology, their origins in time, geology and evolution, about the techniques of exploiting them, agriculture and engineering. But the concept of a current with droughts and freshets, backwaters and sandbars is left to inference. To learn the hydrology of the biotic stream, we must think at right angles to evolution and examine the collective behavior of biotic materials. This calls for a reversal of specialization. Instead of learning more and more about less and less, we must learn more and more about the whole biotic landscape. Ecology is a science that attempts this feat of thinking in a plane perpendicular to Darwin. Ecology is an infant just learning to talk, and, like other infants, is engrossed with its own coinage of big words. Its working days lie in the future. Ecology is destined to become the lore of the Round River, a belated attempt to convert our collective knowledge of biotic materials into the collective wisdom of biotic navigation. This, in the last analysis, is conservation. Conservation is a state of harmony between men and land. By land is meant all of the things on, over, or in earth. Harmony with land is like harmony with a friend. You cannot cherish his right hand and chop off his left. That is to say, well, darn it. You cannot love game and hate predators. You cannot conserve the water and waste the range. You cannot build the forest and mine the farm. The land is one organism. Its parts, like our own parts, compete with one another, and cooperate with one another. The competitions are as much a part of the inner workings as the cooperations. You can regulate them cautiously, but not abolish them. The outstanding scientific discovery of the 20th century is not television or radio, but the complexity of the land organism. Only those who know the most about it can appreciate how little is known about it. The last word in ignorance is the man who says of an animal or a plant, "What good is it?" If the land mechanism as a whole is good, then every part is good, whether we understand it or not. If the biota, living things, in the course of eons has built something we like but do not understand, then who but a fool would discard seemingly useless parts? To keep every cog and wheel is the first precaution of intelligent tinkering. Have we learned this first principle of conservation, to preserve all the parts of the land mechanism? No, because even the scientist does not yet recognize all of them. In Germany, there is a mountain called the Spreestart. Its south slope bears the most magnificent oaks in the world. American cabinet makers, when they want the last word in quality, use a Spreestart oak. The north slope, which should be the better, bears an indifferent stand of Scotch pine. Why? Both slopes are part of the same state forest. Both have been managed with equally scrupulous care for 2 centuries. Why the difference? Kick up the litter under the oaks, and you will see that the leaves rot almost as fast as they fall. Under the pines, though, the needles pile up in a thick duff. Decay is much slower. Why? Because in the Middle Ages, the south slope was preserved as a deer forest by a hunting bishop. The north slope was pastured, plowed, cut by settlers, just as we do with our woodlots in Wisconsin and Iowa today. Only after this period of abuse was the north slope replanted to pines. During this period of abuse, something happened to the microscopic flora and fauna of the soil. The number of species was greatly reduced. In other words, the digestive apparatus of the soil lost some of its parts. 2 centuries of conservation have not sufficed to restore these losses. It required the modern microscope and a century of research in soil science to discover the existence of these small cogs and wheels which determine harmony or disharmony between men and land in the Spreestart. For a biotic community to survive, its internal processes must balance, else its member species would disappear. That particular communities do survive is well known. Wisconsin, for example, in 1840, had substantially the same soil, fauna, and flora as at the end of the last ice age, 12,000 years ago. We know this because the bones of its animals and the pollens of its plants are preserved in peat bogs. The successive strata of peats, with their differing abundance of pollens, even record the weather. Thus, around 3000 BC, an abundance of ragweed pollen indicates either a series of droughts or a great stamping of buffalo or severe fires on the prairies. These recurring exigencies did not prevent the survival of 350 kinds of birds, 90 mammals, 150 fishes, 70 reptiles, or thousands of insects and plants. That all these should survive as an internally balanced community for so many centuries shows an astonishing stability in the original biota. Science cannot explain the mechanisms of stability, but even the layman can see two of its effects. Fertility, when extracted from rocks, circulated through such elaborate food chains that it accumulated as fast or faster than it washed away. The geological accumulation of soil fertility paralleled the diversification of flora and fauna. Stability and diversity were apparently interdependent. American conservation, I fear, is still concerned for the most part with show species. We have not yet learned to think in terms of small cogs and wheels. Look at our own backyard, the prairies of Iowa and southern Wisconsin. What is the most valuable part of the prairie? The fat, black soil, the cherosum. Who built the cherosum? The black prairie was built by prairie plants, 100 distinctive species of grasses, herbs, and shrubs, by the prairie fungi, insects, and bacteria, by prairie mammals and birds, all interlocked in one humming community of cooperation and competition, one biota. This biota, through 10,000 years of living and dying, burning and growing, praying and fleeing, freezing and thawing, built that dark and bloody ground we call prairie. Our grandfathers could not know the origin of their prairie empire. They killed off the prairie fauna and drove the flora to a last refuge on railroad banks and roadsides. To our engineers, this flora is merely weeds and brush. They ply it with grader and mower. Through processes of plant succession predictable by any botanist, the prairie garden becomes a refuge for quack grass. After the garden is gone, the highway department employs landscapers to dot the quack with elms and artistic clumps of Scotch pine, Japanese barberry, and spirea. Conservation committees en route to some important convention whiz by and applaud this zeal for roadside beautification. Someday we may need this prairie flora not only to look at, but to rebuild the wasting soil of prairie farms. Many species may then be missing. We have our hearts in the right place, but do not yet recognize the small cogs and wheels. In our attempts to save the bigger cogs and wheels, we are still pretty naive. A little repentance just before a species goes over the brink is enough to make us feel virtuous. When the species is gone, we have a good cry and repeat the performance. The recent extermination of the grizzly from most of the western stock-raising states is a case in point. Yes, we still have grizzlies in Yellowstone, but the species is ridden by imported parasites. The white rifles wait on every refuge boundary. New dude ranches and new roads consistently shrink the remaining range, and every year sees fewer grizzlies on fewer ranges in fewer states. We console ourselves with the comfortable fallacy that a single museum piece will do, ignoring the clear dictum of history that a species must be saved in many places, if it is to be saved at all. Stop there. As I said, we're going to do a lot of reading in this unit. Thoughts? There's a lot of vocabulary in there that I think is probably unfamiliar to you. Did you feel like that? Okay. So what I'm going to do, we have that wonderful system of annotation that Mrs. McNally uses. How many of you have Mrs. McNally for English? I think most of you. So you're already familiar with it. If you're not, I've got her materials, and we're going to do some annotation with some work of Alva Leopold's and also a couple other books. So we'll get you some practice in lots of places. We'll stop there. Tomorrow you will have notes to get in one form or another, and we'll pick up starting with ecology.